This is Unit 3, Lesson 1, the chain rule. So this is another differentiation rule that is very useful, and it works with composition of functions. So a lot of times a function isn't just like y equals the square root of x, or a polynomial, or just like y equals sine x. There's usually more involved, so it looks like a composition of function. So something like y equals the square root of x cubed plus 2, or y equals sine x squared. So what we have is we have one function that is inside another function. That's why it's a composition. So if we were to separate that using f and g, we would write f of g of x is going to be the square root of x cubed plus 2. So how do we find the derivative of that? Because we have a function inside a function. So that's where the chain rule comes in. So the chain rule says that f and g are differentiable, and then the composite function, fg of x, is differentiable, and it becomes f prime of g of x times g prime of x. Now Leibniz would want us to use a u substitution, and I'm going to do one of the problems using u substitution, because we will be using u substitutions in the future, so for some more sophisticated techniques. So it's important that you understand how the u substitution works. So what you do is you let one function be f of u, and the other one is u, the inside function is u. So now you really are just doing like a power rule or something. And then you can see that y is a function of u and u is a function of x. So we have dy dx becomes dy du times du dx. And like I wrote there, it looks more complicated, but it really says multiply the derivative of the inside function by the derivative of the outside function. So, for example, when we don't have the chain rule, we would have to do the next example this way. So we would first have to take f of x and multiply it out. So f of x becomes 25x squared plus 30x plus 90. So now, plus 9. So then we would have to take the derivative of the polynomial, and we get 50x plus 30. Now using the chain rule becomes a lot quicker. So here's what we do. So f of x is x plus 3, that binomial squared. So f prime of x is going to be, we're going to take the derivative of the outside function, which is a squared function. So we bring the 2 down, we lower the power by 1, so it now becomes 2 times 5x plus 3 to the first power. Then we're going to take the derivative of 5x plus 3, which becomes 5. So what you have here is this part is f prime of g of x, and the 5 is g prime of x. When we define f of x as x squared and g of x as 5x plus 3. So our final answer is going to be f prime of x is going to be, multiplying this together, 50x plus 30. So you get the same answer. Okay, now the next one I'm going to first do using u substitution, and then I'm going to just do it using the chain rule. So it's pretty straightforward. So what we're going to do is you let u be the inside function. So it's going to be 4 minus x squared. Then you take the derivative of u, so u prime is going to be negative 2x. Okay. So remember, that's du dx. So now what we're going to do is we're going to substitute that into the function. So now we have f of u is going to be u to the third power. And now we're going to take the derivative of that. So f prime of u is going to be 3u squared. And at this point, you substitute back in everything you have, except I didn't do the whole derivative. It's 3u squared u prime. Okay, so now we substitute everything back in. because we want this to be a function of x. So f prime of x is going to be 3 times u squared, which is 4 minus x squared to the second power, because that was our u, times u prime, which is minus 2x. And then you simplify, so you get negative 6x times 4 minus x squared squared. Okay, which would be the same if we just did the derivative of the outside times the inside. So if I were to do that, what I would do is I would bring the power down. So f prime of x would be 3 times 4 minus x squared, lower the power by 1 squared, and then take the derivative of the inside. So then that would be negative 2x. And if you notice, these match up completely with what we did with our u substitution. So we get negative 6x times 4 minus x squared squared. So you don't have to go to all the trouble of the u substitution, but I just wanted to do one to show you. Okay, so some things to remember is that what we did in the last example was a version of the power rule, and that is listed right here. So we have a function raised to a power, so you bring the power down, you lower the power by 1, and then you take the derivative of the inside. And the other one is our e derivative. So what we have here is we're going to keep e to the gx, because e to the x is the only function, it's its own derivative, and then we have to multiply that times the derivative of g. So let's do a few of these here at the practice section for exercise 3. So the first one, f of x equals the square root of x squared minus 1 cubed. So you want to remember that you can think of this as x squared minus 1 to the 3/2 power. That might be a little easier. So f prime of x is going to be, I bring the power down, I'm going to keep that inside function, lower the power by 1, and then take the derivative of the inside function. So when I multiply everything together and simplify, I get that f prime of x, the 2's will cancel, I'll get 3 times the square root of x squared minus 1. Okay, I'll leave letter B for you to do. Very similar. Let me do NC. That's also pretty similar. And then let me do letter D. So letter D is an E function. So what we're going to do is find y prime by rewriting our E function. So it's e to the 3x squared, because e is its own derivative. And then we have to take the derivative of the 3x squared, so we get 6x. So y prime is going to be 6x e to the 3x squared. Okay. And I will do the cosine one, and I'll leave the other 3 for you to do. So with the cosine one, you want to remember, you want to think of this as cosine of e to the 5 theta, and that's all raised to the 3rd power. So we got a lot going on here. We got 2 inside functions here. So y prime, we're going to start by doing the power rule. So we're going to bring that 3 down. We're going to lower the power of the cosine by 1. We're going to keep the inside part. Now, the next thing we have to do is take the derivative of the inside part, which is the cosine, the first cosine. Whoops, I don't want an equal sign there. So this is going to be multiplied. So I have to take the derivative of cosine, which is negative sine e to the 5 theta. Now I still have a function inside of that, so I have to take the derivative of that inside function, which is going to be the derivative of 5 theta, which is 5, and then e to the 5 theta. So here I had 2 functions inside one function. So simplifying, I get for a final answer, y prime is going to be negative 15 e to the 5 theta cosine squared e to the 5 theta. Whoops, that should be an e, not a 5. E to the 5 theta times sine e to the 5 theta. Okay, so you just keep working your way inside. So we did the power first, then we had to take the derivative of cosine, which is negative sine, and then we still had a function inside there, so we had to take the derivative of e to the 5 theta. Okay, so pause the video at this point and do the other 3, and I'm going to post the answers. Okay, there are the other 3 problems answers, and again, as always, if you have questions on the answers, please ask in class tomorrow. So I'm going to finish this video at this point, and I'm going to finish lesson 1 in the next video.